In this video, I'm going to look at one of the applications of differentiation, which is finding the equation of a tangent to a curve. In this example, I'm going to find the equation of the tangent to the curve f of x equals 3x cubed minus 2 at the point where x is equal to -1. Now, just for reference sake, I'll call this first equation equation 1, so we can refer back to it a little bit later on. Firstly, in order to find the equation of the tangent, we need to find the gradient of the tangent line at this point where x is equal to -1. So firstly, we'll find the derivative of equation 1. And the derivative of equation 1 we write down as f dashed of x, and it's equal to 3 by 3x squared. And of course the derivative of 2 is just 0, so just 3 by 3x squared. If we simplify that, it becomes 9x squared. So at the point where x is equal to -1, f dashed of -1 is equal to 9 times -1 squared, and that's equal to 9. So the gradient of the tangent we now know to be 9. Let's let the equation of the tangent be of the form y equals mx plus c. That's just the standard form for a straight line, and we know the tangent's going to be a straight line. Now, we already know the value of m in this equation, m being the gradient, of course. So we know that our equation is going to be y equals 9x plus c. M is the gradient, so y equals 9x plus c. And I'll call that equation 2, again, so we can refer back to it later. Now we need to find the value of c, and we go about doing that by referring back to equation 1. We need to actually find f of -1, so we need to substitute x equals -1 into our original equation, and that gives us f of x equals 3 times -1 cubed minus 2, and that's equal to -3 minus 2 or -5. So we now know that -1 minus 5 is a point on the original curve, and it's also a point on the tangent. And if we have a look at the graph, we can see this point, the tangent point, at x equals -1, y equals -5. That point is a point on the straight line, which is the tangent, and it's also a point on our original curve. So if we substitute x equals -1, y equals -5, or that point, into the equation for our tangent, which is equation 2, then we get -5 equals 9 times -1 plus c, and quickly rearrange that, we can see that c is equal to +4. So the equation for the tangent line that we've been looking for is y equals 9x plus 4.